BMED Unit 2, Lines and Planes in Space. Of course, your presenter, Courtney Vassell. Lines and planes in space. For this unit, we will learn how to identify geometric concepts like points, lines, and planes in space along with their properties. Euclid is the father of geometry. The word geometry comes from the Greek prefix geo, which means earth, and the suffix metry, which means process of measuring. Now, his writings on solid geometry, plane geometry, and in particular points, lines, and planes are all geometric concepts that relate to positions in space and provide a starting point to identifying all other geometric concepts. All these combine to help us understand elements in the world and beyond. Now, we're going to be looking at three basic concepts. One is a point. So, a point is a location in space that has neither shape nor size. However, in order to be able to model this concept, we use a small dot to represent the idea of a point. A point is usually defined by a capital letter. Case in point here, this point, we refer to it as point A, point B, or point C, whichever. Next point, the next concept is a line. A line is connected set of points that extends infinitely in two directions. A line passing through points A and B can be named in several ways. So here we have mark you that a line is always labeled, whether it is AB or BC but it's always labeled. You always reference, we call it referencing your lines. The next point or concept is plane. So a plane is a two-dimensional surface made up of points that extends infinitely in all directions. There exists exactly one plane through any three non-collinear points. All right. Now, in terms of how we'll be approaching the lecture series, this will be a lecture series of lines in space. We'll attempt to give you the descriptions as to what we'll be covering. All right. So at the end of the unit, we'll be able to, one, define a trace, construct the trace of lines inclined to the horizontal plane, HP, construct trace of lines inclined to the VP, which is the vertical plane, construct traces of planes, determine line of intersection, construct true shape of triangular lamina, determine the dihedral angle, and skewed lines, that is determining the shortest distance between two lines. All right, so we're going to start off with defining the trace. Traces of lines. So a trace is a point at which the line or its extension meets the horizontal plane or the vertical plane. Again, the trace is a point at which the line or its extension meets the horizontal plane or the vertical plane. A line will show the horizontal trace if it is inclined to the HP. Likewise, a line will show the vertical trace if it is inclined to the VP. We're going to further demonstrate this. All right. However, what I want you to know is that a line that is parallel to either the VP or the HP will have no trace. So as long as the line is parallel to the plane, whichever the plane is, whether it be the horizontal plane or the vertical plane, that line will be said to have no trace. All right. Now let's use this now to further explain all the nuances with what you just read a while ago. All right. So over here, so we're looking at the traces of a line inclined to the horizontal plane. Then we're going to look at the trace of a line inclined to the vertical plane. This diagram over here would be our pictorial representation of the concept that we want to understand. All right, so here we have a line AB, and this line AB is inclined to the horizontal plane. So this would represent our horizontal plane, while this here would represent our vertical plane. So this plane here would be our vertical plane. Once we look at the line from this view, then this now would become our front. So this will be the front of the line, and the front is projected in the vertical plane. Now, once we look from the top of the line AB, what we will see projected in the horizontal plane is our plan. So this then would be, or would represent, our plan, the view looking from above. Now, notice that the line that is inclined to the HP, once it is extended, see we have the extension here, once the extension touches the HP, this extension is referred to as our trace, and that would be our horizontal trace. All right, now of course we're going to have our XY, so this is our XY, which defines our point where the horizontal would meet the vertical. All right, over here we're going to have our orthographic presentation, which of course what this would be, it would be the unfolding of these two planes, right? So with our XY in the middle, we'll unfold this. So this will go to the bottom and while this goes to the top. So you'll see right here. Just in case you're wondering, the distance from here and the distance from here is represented here. The distance here will be the distance here. The distance here would be the distance there, right? And of course, this is said to be parallel, so the distance from here and distance from there is the same. All right, so this would be the plan. So looking at the line from the top, and this would be the front, looking at the line in this direction. So what we notice here is that this is our VP and this is our HP, right? So once the line is extended, so once this line is extended, we will get our H, and that's the trace, right? So it'd be the horizontal trace. When you understand something, you see, once it's coming from VP, you're gonna get H. If it is coming from HP, you're gonna get V. We'll show you that in a subsequent video. All right. So now, where the extension touches XY here, we extend this down perpendicularly, and we have this line extended from the plan. So this point here would be our exact location of the horizontal trace. Of course, that's our VP and our HP. All right, so